Okay, this is notes for section 2.4. It should be Thursday, okay, complex numbers. All right, we already know a lot about complex numbers because we did them last year, so this shouldn't be too hard for you, hopefully. Once again, most of this is review with just a little bit of extra added to it. So what we're going to do is we're going to start off by talking about standard form for a complex number. Okay, standard form for a complex number. Is going to be A plus BI. Okay, A is going to be your constant, and then this is going to represent your complex number or your imaginary part. So what we're going to do first is we're just going to talk a little bit about adding complex numbers. It's really easy. I'm just going to give you some examples, and what you need to do is just treat these as if they were like terms. Even though the I is not like a variable, we're going to treat it like that as we work through these. Okay, so if I was adding 4 plus 7x plus 1 minus 6x, you would just combine your like terms. So you're going to put the 4 and the 1 together, and that's 5, and the 7i minus 6i, that's I, and you simplified, and that's all you have to do. Just put it in standard form. See, that's A plus BI. A is represented by the 5, and BI is represented by I. And you don't have to write that down, but you just need to write the answer and realize that you're in standard form because it's in A plus BI form. Okay, that's number 1. Here's number 2 example. And we have 1 plus 2i minus 4 plus 2i. So again, you're going to do the same type of thing, paying special attention to that subtraction in between. You might want to go ahead and distribute that. Minus 4 minus 2i. And then you put your like terms together. I'm going to keep my constant together. So 1 minus 4, I'm going to put those together. That gives me negative 3. And then those 2i's cancel out. So negative 3 would be your answer. Standard form might look something like this. Negative 3 plus 0i. But you really don't even have to put that. Just the negative 3 would be fine. Okay. Now then, here's one with a few more terms in it. 3 plus 2i in parentheses, and plus 4 minus I in parentheses, and then minus 7 plus I. So just a few more terms. We're doing the same thing. Again, we're just treating these like terms. So I'm going to go ahead and get rid of those parentheses. That way I can apply any negative that I have. Notice nothing's changing on these first parts because there's a plus in between. But this one will change. The 7 will become negative, and the I will become negative. And then I'm going to put my like terms together. Okay, and I'm going to go ahead and do my constants first. 3 plus 4 is 7. Minus 7, so all the constants go away. And then we'll put in the i's, and you've got 2i minus I, well that's 1i, and then minus I, so that just goes to 0. So that's simplified all the way down. So adding and subtracting is really, really easy. It's not very hard at all. Just treat it like it was a regular variable. Okay, properties that you can use in imaginary complex numbers, okay, would include these right here. The associative, remember, that's what we just did with parentheses. So associative applies. Okay, you can also use the commutative property. That's where you can add or multiply in any order. So the commutative property applies. And then your distributive property. And we've already kind of used all 3 of those, except maybe the associative property. So what we're going to do is we're just going to do another example of using the distributive property, okay, because we're going to multiply some complex numbers. And we always want to put our answer in standard form. So if for some reason it's not in standard form when you finish it, you're going to maneuver it so that you can get it into standard form. All right, we're going to distribute. 4 times negative 2 is negative 8. and 4 times 3i is 12i, and that is in standard form, so your answer is 8 plus 12i, and that's all you do. Okay, next example would be an example of the commutative property, which we know as FOIL when we're multiplying binomials. Okay, so it's really just the distributive property. Okay, it's really just the distributive property. But that's two binomials. That's just like 2 minus x, 4 plus 3x. So first times first would be 2 times 4. That's going to give us 8. Outside would give us positive 6i. Okay. Inside would give us negative 4i. And then your last terms, negative I times positive 3i, would be negative 3i squared. And this is where you need to be really careful and watch closely, okay? We're going to put these inside terms together like we always do. So that's 8 plus 2i, because the 6i minus 4i is 2i. And then you have to be careful with this one. That's actually going to end up being plus 3, because what you remember, okay, is that I squared is equal to negative 1. I squared is equal to negative 1. That's from last year. I squared is equal to negative 1. So what we really did is we replaced this I squared with a negative 1. That would give you negative 3 times negative 1, and there's where the positive 3 comes from. And then you want to add those together. So that's 11 plus 2i. Now you're in standard form. Okay? So what you want to remember about that is that I squared is equal to negative 1. So anytime you end up with I squared in a problem, you're going to simplify it by plugging in a negative 1 for I squared. Okay, now then we're going to do one that this is a special product pattern. Again, we know this from Algebra 2, so it shouldn't be too hard. 3 plus 2i, 3 minus 2i. That's a plus b, a minus b. So remember, we square the first, we square the second one, and we put a minus in between. Okay, and hopefully you see that there's an I squared there, so you're going to replace that with a negative 1. Okay, so I'm going to make that 9 minus 4 times negative 1. So that's really just 9 plus 4, which simplifies to 13. Okay, and you don't have to put 13 plus 0i, but you can see that because I squared is negative 1, you make that replacement and you simplify it to 13. Okay, now here's our favorite that hopefully everybody's good at. This is a binomial square, and you're not going to square each term. You're going to do square together, double square. Okay, so we square the first one, we get 9. Together is 6i, doubled is 12i. Okay, and then we square the 2i and get 4i squared. Again, we've got to replace that with a negative 1. So that's 9 plus 12i minus 4, because the I squared was replaced with a negative 1, and negative 1 times 4 is negative 4. Now when you put that together, the 9 and the negative 4 come out as 5 plus 12i. And then you're in standard form. There's a plus bi, and that's your answer. So this is a really, really easy section. Shouldn't be too hard for you. Just a couple more things, okay? What we want to remember is complex conjugates. When we rationalize a denominator, that's a way of getting rid of a radical. Well, in the same way, you don't want to leave i's in denominators, so we use what we call complex conjugates, and that helps us simplify. Okay? Complex conjugates. Now I'm going to want you to know that terminology, so be sure you mark this down. Complex conjugates. Okay, so for example, if I gave you 1 plus I, the complex conjugate, I'm going to call it CC, is 1 minus I. Okay, and every time that you multiply complex conjugates together, you're going to get a single number. Okay, so for example, we just did it a while ago. 1 plus I, 1 minus I. Don't we square the first, square the second, put a minus in between? So that's 1 minus I squared. You know to replace your I squared with a negative 1. So isn't that 1 plus 1, which is just 2. So that gets rid of the i's, and that's a good technique to have if you're needing to get rid of the i's, and I'll show you when you need to do that in a minute. Okay, so if I gave you 4 minus 3i, and I told you to multiply that by the complex conjugate, okay, directions, multiply by complex conjugate, then you're going to say, okay, 4 minus 3i, and I'm going to multiply that by the conjugate, which is 4 plus 3i. And I know from my special product patterns that I square the first, square the second, put a minus in between. I'm dealing with i's. I know the rule for I squared equals -1. So that really gives me 16 plus 9, which equals 25. So that's a complex conjugate. And that's how they simplify. Okay, I'm going to go ahead and stop this video. And I'm going to go into part 2 so that it's easier for me to download. So look for section 2.4, part 2. You've just taken notes on part 1, I'll add part 2.